we will start with the first homework, and the two homeworks, and they involve all chapters included for the midterm from the beginning until work and energy. Okay. And as I told you, I will send you the correction file كمان with some comments on errors done and how we should correct them. Yeah, the file is opening. 1 second. Okay, so for the first problem, sketch a V versus T curve for each of the following conditions. So هول مثلا these questions are review for graphs, how to do graphs. So in the first part, we want to plot V function of T for the case of constant acceleration but not zero. Okay, so we know that A is derivative of velocity with respect to time. So if A is constant, then V is linear with time. Okay, so one possibility, we have several possibilities for graph A. You can have a, they didn't mention the sign of acceleration. So you can just draw a straight line in V function of time. It can be of positive slope. It can be of negative slope. Both are right. Okay. Now, second graph, velocity and acceleration are both positive. So to have positive acceleration, the slope of V should be positive. And to have V positive, it should be in the upper part of the graph. Yani this graph like this will represent V positive and A positive, because the slope then will be positive. And since I am in the upper quadrant, then V is positive. Okay. If they want, for example, A positive, V negative, you can do this. This is your graph. This is time. This is velocity. So if I draw the graph like this graph has a positive slope. So in this graph, A is positive, but the value of V is negative because I am below T axis. So for this graph, it's V negative. And then it's a deceleration motion, a decelerated motion, because A times V is negative. We said that we have acceleration when A and V have same sign. In 1D أكيد عم نحكي. Because if you have a curvilinear motion, then A will be decomposed into A tangential and A normal. Okay. And the condition to accelerate in normal tangential coordinate is that A tangential times velocity should be positive. But when we talk about 1D motion, if you are moving on a straight line, then you don't have normal acceleration, you only have A tangential. This is why we just say A times V. Now, for the third graph, they want you to present the case of velocity and acceleration both negative. In this case, I should have the following graph, for example. Since V is negative, I should put the graph in this part below the T axis. And because A should be negative, so I have a decreasing V. So that's the slope. The slope of V will be negative then. Okay. Any question on how to draw these graphs? Now, if the velocity is negative and acceleration is positive, then I will work in the lower part below T axis to have a V negative. And since acceleration is positive, so I should have a positive slope. So this is E. Finally, velocity is momentarily zero, but the acceleration is not zero. So I want to represent a graph where the velocity will pass by 0, but at this point the acceleration is not 0. حدا في يقول لي how can I do this? Who can give me an example where the velocity will have a value of 0 but the acceleration is not?
يكون في عنا لاين مارق بالاكس اكسس بس هو عنده سلوب.
Very good. So the easiest example is this one. I have, this is my VT axis, and I have V linear, let's say, and it's passing by T axis. So at this point here, at this instant, the velocity is 0, but the acceleration for the whole motion is constant, is equal to a negative value. Another example also, if you have, let's say, and you can have any profile. If you have velocity variation like this, for example.
فينا نحط البارابولا؟
نعم فينا نحط البارابولا أكيد فينا نحط بارابولا. إذا هون عندي curve هيك مثلا، هون ما slope when it will intersect the T axis بتكون V0, بس if you draw the slope, A represents the slope of V with respect to time. So the slope at locations where V is 0 is not 0. Then I am in the case of of 0 velocity and an acceleration different than 0. هلا إذا بدي V وال A اثنيناتهم يكونوا 0، مين في يعطينا example at a certain point؟
Santa, you need to have the intersection point be the max or minimum.
Exactly, very good. If the intersection point with T is a maximum or a minimum, then at this point V is 0 and A is 0. For example, like this. Let's say this is a parabolic profile and its maximum is will take place at the axis T. So this corresponds to a horizontal tangent line. So if I draw the tangent at this point, it's characterized by a slope of 0 because the tangent is horizontal. And if I consider what is the value of the velocity at this point, the velocity at this point is also 0 because I am intersecting the axis. So this is an example where at this point I will have V0 and A0. So here V equals 0 and A0. Okay. So they can, this type of question will be included in general in the MCQ. So as we have seen in previous so they can give you several graphs and ask you which of the following is true, and you select the corresponding answer. Another problem. Let me zoom in it a little bit. Okay. How far does the runner whose velocity the word document is not, so zoom is not acting on the document. Let me check. Oh, 1 second, sorry. Okay, yeah, it's working now. So in problem 2, they gave us graphs and they are asking to find how far does the runner whose velocity time graph is shown in the figure, right, travel in 16 seconds. The figure's vertical scaling is set by V versus what? by Vs equals to 8 meters per second. Okay. So here in this problem, they gave you the velocity graph function of time. And they want you to find what is the total distance traveled in 16 seconds. If you want to graphically determine the total distance traveled by the runner, how can you do it graphically? What should
by
you
the
do?
area.
The area, because we know that delta x is equal to integral v dt, and integral v dt represent mathematically the area under the graph. So here I should determine the total area under the graph. To do this, I need to sum all areas below this graph, so I can decompose this area into several parts. The first part is this this part here. So this is part 1. Here I have a trapezoid. I can use the formula of area for a trapezoid. If I don't know it, I can decompose the trapezoid into a triangle, part 2, and a rectangle, part 3. And I have here like a square, so this is area 4, and a triangle, area 5. And just I have to add these areas. So for part 1, and since all of these areas are above t-axis, then they are counted as positive. Okay, pay attention. If you have, for example, a part of the graph above t-axis and another part below it, when you calculate the total area, then you take that this part is, you account it as positive, and this part you account it as negative. So when you do the addition, everything above the axis you count plus this area, everything below the axis it's minus the area. So here for this triangle, the area is 2 times 8 over 2, so it's 8. For this square here, they have that this distance is between 2 and 10, so it's 8. And here also it's 8, so 8 times 8, the area here is 64. For this triangle, you have that the base is 2, the height is 4, so the area is 4 times 2 over 2, it's 4. For this rectangle, the small one, you have 2 times 4, which is 8. So this is 8. And finally, this rectangle, you have 4 times 6, which is 24. So in total, you have 24 plus 8 plus 4 plus 64 plus 8. This is how you get the total distance in meter. So these are problems are relatively simple. And let us continue. Okay. Now, in figure 3 here, the figure to the left, a graph of a particle's position along an axis versus time is given. We want to determine at what time, at time t equals 0, what is the sign of the particle position? Is the particle velocity positive, negative, or 0? And also we'll investigate acceleration, if it's positive or negative. So let us do the analysis of the graph. So first, this is x function of time. This graph represents the variation of position with time. Okay, at each, if they specify a certain time for me at t equals 0, they want to know the sign of particle position. This is the simplest question, because I can directly read x on the graph, because this point is below t-axis, so x is negative. Okay, now to know the sign of velocity at this point, I should draw the tangent. If I draw the tangent at this point, it will be clear that it has a positive slope because I have an increase in x. So if you draw the tangent, and if they want you to find what is the value of velocity, you should draw the line and say that the velocity represents the slope of this line. So you take any 2 points on this line, try to take them a little bit far from each other to reduce the error. So you measure delta x using the scale of the figure. You measure delta t, and you say that the velocity at this point is equal to the slope, which is delta x over delta t. And this will allow you to calculate the velocity at this point. Okay. Now, they are asking for the sign of velocity at different times. So we want to know if the velocity is positive or negative at times 0, 1, 2, and 3 seconds. And we want to know how many times will the particle go through x equals 0. So first, for the sign of velocity, all I have to do is to look at the slope. So as we said, at t equals 0, it's a positive slope, positive velocity. At t equal 1, still positive, but as you can see, the slope is decreasing. So if you compare velocity at 1 with velocity at 0 seconds, velocity at 0 seconds is larger than velocity at 1. And at 2 seconds, the slope is horizontal, so the velocity is 0. While at 3 seconds, the velocity becomes negative. So in the other part, in this part, v is negative. Now, what about acceleration? Can you tell me what is the sign of acceleration for t equals 0, 1, 2, 3 seconds? What is the sign of A?
Positive, at 1 positive, at 2 it's constant, is equal to 0 v. At 3 it's كمان it's negative.
No, this is the velocity, Hassan, not the
No,
acceleration.
better.
Acceleration, I'm talking about A.
Oh,
How,
acceleration. Oh,
you
okay,
remember how we find the sign of A? What should we look at? What is the
نطلع كيف شكل السكاتش تبع البارابول ولا لا؟
Exactly. بدنا نطلع على concavity of the parabola or of the curve. You know that A is dv by dt. A is the first derivative of velocity with respect to time. Now, if I talk about x with respect to x, A is the second derivative of x with respect to time. So because A is the second derivative of x with respect to t, then it represents the concavity of the graph. So if the concavity is upward, A is positive, smiley face. If the concavity is downward, A will be negative. Here, I have downward concavity at all points, okay? Sometimes you can have the graph varying like this. If the graph is varying, you have zones of positive concavity, zones of negative concavity. So for example, here, this part is negative concavity, A is negative. Here, positive concavity, A is positive. And for the inflection point, which is the transition between the two zones, the acceleration will be 0. Okay, so this is how you can track sign of A. You look at the concavity of your graph. Here, the concavity is not changing. My graph is concave downward. Okay, so it's so we can say it's convex. Concave, it's like this. Convex is like this. Or we say downward concavity and upward concavity. Okay, so in this case, we have A is negative at all times. حتى على 2 حتى على 2 مالنا 0. في كتير بغلطوا بيقولوا على 2 0. No, because when you calculate concavity or A, you should take the point v after minus v just before over delta t, and it will not be 0 because the velocity here is positive, the velocity here is negative. So you will do, let's say for example, the velocity here is +1 and the velocity here is -1 and delta t is 1 second, for example. I'm taking an example just for you to see how. So -1, I take v after minus v before, so -1 over delta t. So I will get that at this point the velocity, the value of a is negative. Okay. So I cannot say that a is 0 at the maximum. At the maximum, the velocity is 0, but a is not. A is negative everywhere because the concavity is downward for my graph. Okay. Any question on
بس
this?
الفيلوسيتي عم ترجع تزيد يعني
الفيلوسيتي
تزيد
عم
على
بتزيد
negative.
عم بتزيد in magnitude بس عم بتقل in إذا بدك ك numerical value. يعني أنت algebraically it's decreasing بس in magnitude it's increasing. يعني عم بتصير more negative هالمال. هذيك المال كانت عم تصير more positive. بما انه عم بتصير more negative ال velocity, the acceleration will be negative.
اوكي بس انه ايه عم تصير نيجاتيف اكثر.
ما منشان هيك انت باول زون V كانت positive و A negative، فشو بتكون التايب اوف موشن باول بارت؟ بتكون deceleration لانه V عم بتخف in magnitude، بينما in the other side V will become negative and A is still negative. A ضلت constant. يعني it's a parabola. The value of A is constant. هتطلع minus something. So in the second phase, both velocity and acceleration are negative. يعني you have acceleration. لأنه the velocity magnitude is increasing but in the negative direction. Okay, عم بتصير more negative يعني it's accelerating.
اوكي
Okay. طيب. Now, how many times the particle will go through x equals 0 through the origin? How you know how many times the particle will go through the origin?
بس تكون ال V 0 ولا لا؟
لا. ال V0
على
يعني change in sense. ال X0 طلع بهالجراف. هذا
مطرح
الجراف.
ما قطع الجراف بالتي
1 و 3.
Yes, exactly. When it will intersect t axis لأنه t axis correspond to x equal 0. So to know how many times it will pass by 0, I just look at the intersection. It will intersect this axis at t equal 1 and at t equal 3 seconds. إذا بقول لكم حيلا x تاني يعني how many times it will pass through x equal -2 مثلا, you draw the line corresponding to x equal -2. إذا عم ناخذ scale مثلا each square is -1, so -1 -2, you draw the line كمان it will pass by -2 two times. في point واحد بتمرق فيه once اللي هو مين؟
الماكسيموم.
maximum corresponding to x equal 1. Okay, so this is the maximum possible x. إذا بيطلبوا مني x higher, I will not be able to pass by x higher than 1. Okay. Let us continue. You drive on a highway and you have from a certain point هنسميه, so you are driving from point A to point B. Half the time at 110 kilometers per hour and the other half at 130 kilometers per hour. So you are changing You are changing your velocity during motion. And in phase 1, so we'll divide motion into 2 phases, phase 1 and phase 2. Okay. Now, on the way back, when you come back from B to A, you travel half the distance at 110 km/h and the other half at 130 km/h. Now, they are asking several questions. Let me go to a white screen and to do this problem. This is an important problem. So you have, I will take the given, one second.
دكتور it's fine اظبطي كمليها after the remaining time بعد في 3 دقايق احنا ما تكوني
طب
عملتيها
يلا we can open, so let's open a new meeting then. Let's open a new meeting to start it
Okay.
from beginning.
ماشي
Yeah.